In this video, we'll talk about two sinusoidal regression problems. The first one is just going to be with just numbers, and we just figure out what function, the sine function that represents the numbers. And then in the second one, we'll talk about, we'll actually be given a scenario and then kind of extrapolate numbers from it. So before we get started, though, we got to remind ourselves a few things about the sine function, and this applies to the cosine function as well. But in order to be able to write a cosine function, there's a few things we need to know. We need to know the amplitude, which remember is the midway point between the top data and the low data. It's also just the distance from the middle to the top or the distance from the middle to the bottom. And so if we could identify a high value and a low value, we can just find the middle of those and we'd be able to get the amplitude. We also need a vertical shift, and a vertical shift similarly is halfway between, is essentially the average height. So if I had a curve, let's say I had a curve up here, and I had a high value and a low value, if I found the average of those two values right in the middle, that would give me this vertical shift height, which I need. And then the period has to do with how long it takes to start repeating values. So for a sine function, we'd say there. Cosine, by the way, which is usually more convenient for these kinds of problems, those are looking at consecutive maximums or what would be consecutive minimums that we went over there. And then a phase shift that talks about how far left or right. So if we're choosing sine, we're like, all right, this point here, how far left or right did we move to get to where this data is telling us? The same thing for cosine at this point. So with those things in mind, let's take a look at a problem here. All right, so we're given values for x and y. And the first thing we can kind of do is just take the data in and be like, all right, at 0, we can sort of plot this. You don't have to do this step, but you totally can. So what this is looking like is that at 0, I'm at like a 7, and then at 1, I'm at like a 5.8, then at 2, I'm at a 3, then at 3, I'm at almost 0, and then at 4, I'm at -1, and then I go back to that almost 0 value, and then I go back to 3, oh, I don't know what happened to the 3, and then I back to the 5.82, back to, so it looks like just from kind of just not even accurately sketching this at all, that I'm dealing with this cosine looking thing. Okay, and so what can we do here? So let's take this one by one. So the amplitude is going to be the minimum minus the maximum and divided by 2, right? If we take the minimum minus the maximum divided by 2, that's going to give us that distance between the middle of the data and the, well, it gives us the entire height of the curve basically divided by 2, which is what amplitude is. So the amplitude then would be the minimum, sorry, the maximum minus the minimum. I don't know what I'm saying there. Maximum minus the minimum, that'd be a 7 minus a -1, right? Divided by 2. So the amplitude of this is 4. Okay, so if the amplitude is 4, then that's good. Let's get the vertical shift. That's the maximum plus the minimum divided by 2. It's the average height of the maximum and the minimum. And so that's going to be 7 plus a -1 divided by 2, which is going to be 3. So the vertical shift is 3. That's the average height. The period, so this one's interesting. So we've got, here's a maximum, right? This was a maximum that corresponded to this maximum. And then here's another maximum corresponding to this one. And so the distance between these 2 points from 0 to 8 is 8, right? We could go 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. So if the period, if P is equal to, T is equal to 8, we want omega in order to be able to write this function. And we know that for sine, T is equal to 2 pi over omega. So omega is equal to 2 pi over the period, and the period is 8. So 2 pi over 8, and that means omega is just pi over 4. And then the phase shift, it kind of depends what function we want to choose. Do we want to use sine or do we want to use cosine? And for this problem, I would say let's use cosine, because cosine, this is starting at a maximum at our 0 already, and cosine usually, it does this, right? So this doesn't have any phase shift at all. We could use sine though, but then we'd have to take a middle point and see how far over is it till we get to this middle point. And so for that reason, and you're given these obvious maximum values here. So it just makes sense to go with cosine. But you could totally do a sine regression here. Also, it would just involve a phase shift. So we're going to say there is no phase shift here because we're going to use cosine. And so the last step then would be to just write this function. We're going to write it in the form of y equals a, or we could say f of x, I guess. Let's say f of x. F of x is equal to a times the cosine of omega times x minus the phase shift, which we call phi, plus the vertical shift b. So for this one then, a we said was 4. It's cosine. Omega was pi over 4. X, there's no phi, there's no phase shift, and then the vertical shift is just 3. So right there, that is the function, that f of x. This is the function that describes that data there. And so not super challenging. We just need to identify the minimum, the maximum, and the period. And then from there we can choose if we want to use sine or cosine to get what the phase shift would be. Here's a real world example actually. So Ferris wheels. Ferris wheels, if you know what a Ferris wheel is, they go up and down in a big circle. And one of the largest, I think at the time I wrote this, the high roller Ferris wheel in Las Vegas is the tallest Ferris wheel. And so there's some information about it here. Here's what it looks like. Okay, so you get in here at the bottom, and then you get in at the bottom, and you go around, and it takes you take a ride of 4 revolutions, and that ride of 4 revolutions takes 24 minutes. And so what if we wanted to know these things? What if we want to know the maximum and minimum height of a carriage, the period of the function h of t that describes the height of the carriage over time, and then we want to graph that function, and we want to find the equation of the function if we want to find out these 2 other pieces of information after we find the function. So let's just dive into this and see what happens. So it said that you get on the ride at 30 feet. So the minimum height, so for number 1, we know because it says in the problem that the minimum height is 30 feet. And the maximum height, because this thing is diameter, right? If we think about the Ferris wheel itself, the diameter is 520. So right here, this is at 30 feet off the ground. And then we go another 520 up, which means the maximum height is going to be 30 plus 520, or 550. So that's the answer to number 1. That's no problem. Okay, number 2, the period. Okay, if it goes, and I'm looking at this information right here, 4 revolutions in 24 minutes. Well, if it goes 1 revolution, so basically I'm thinking about heights here, right? So if I say it starts there and then it goes around, well, 1 revolution, if 4 revolutions took 24 minutes, then 1 revolution takes 6 minutes. And then right here it starts repeating itself. Remember, cosine is periodic, or sine or cosine is periodic, or circular is another way to say that. And so the period, t is 6 minutes. That's it, right? It takes 6 minutes for this thing to take 1 full revolution. Number 3, we want to graph the function. Okay, so let's set up a x and y coordinate plane, and we're going to say on the x-axis we have time, on the y-axis we have height, and we know that the minimum heights are this is going to be 30 feet. We're going to go all the way up to 550. And the time period, so I'm interested, when I plot cosine, it's nice to have minimums and maximums. And so at time 0, right, time 0 is there, and if it's a full revolution, if 1 full revolution gives me, takes place in 6 minutes, then half a revolution is 3 minutes. So I'm going to divide this up into 3 minutes, just to see what happens. So we'll do 3, then 6, and then 9, and then 12, and then 15, and then 18. Whatever. We don't have to actually go that far. So, all right, so let's plot the points. So at time equals 0, we're at 30 feet. The carriage just is at the bottom. And then at time equals 3, it's up at a maximum. At time equals 6, it's back down to the bottom again. And then it's going to go on another revolution to get up to 9. Another revolution, another half revolution the complete second revolution gets me back down. At 12 minutes, I'd be back at the bottom. 15 minutes, I'd be back up at the top. And then 18 minutes, I'd be back at the bottom. And so if I sketch this graph, it's doing something like this. It's going up, it's going down, it's going up, it's going down, it's going up, it's going down, which makes sense. This is just going to keep doing the same thing. It's what Ferris wheel does. So there's the graph, and something we can actually label on the graph right away is what's the what is this middle line here? Like, how high up is that? Well, what's the midway point between 550 and 30? It's the same thing that we would do before. We would say 550 plus 30 divided by 2, which is the average height, right? That's 580 divided by 2, which is 290. So this height right here is 290. Okay, cool. Like, this is a lot of useful information. So now let's answer. So that's 3, right? We graphed it. There it is. Okay. 4. Find the equation. All right, find the equation. So 4, h of t, or height as a function of time, right? We're going to want this height as a function of time is going to be a, and we're going to use cosine here because look, it starts at a minimum or a maximum, so we're going to use negative cosine, and then we'll have omega x x minus phi and plus b. Okay, so some things we're missing then, right? We want to know what is omega. Well, omega is going to be 2 pi over 6, because 6 is the period, and so omega then is pi over 3, so that's nice. Then we're going to go with cosine, negative cosine. There's going to be no phase shift. So all we have to do then is write this. We're going to have a negative cosine curve. It's going to be negative, and the amplitude. Oh, we didn't get the amplitude. So what's the height here between the midline and the top? 550 minus 290, or 290 minus 30. It's 260, right? So 260, and then it's cosine. And then we're going to do omega, which is pi over 3 with no phase shift. And then the vertical shift is the average height, which is 290. So boom, there's your function. Oh, it's not x, it's t, right? We're using t. So there's your function of height in relation to time on your way around this Ferris wheel. So that's nice. And then let's answer these other questions. So these ones are a little bit more difficult now. It says, if the ride stops after 14 minutes, how high up is the carriage that started at the bottom? Well, that's just asking me to find what is h of 14. Well, it's fine. We have the function. We just plug in 14. So this is going to be h of 14 is going to equal negative 260 times the cosine of pi over 3 times 14 minutes plus 290. Okay, and then 14 pi over 3, this is just going to be 14 pi over 3, right? Let's look at inside here. 14 pi over 3, we know that cosine is periodic, so every 2 pi, if I subtract 2 pi from this, we're going to just get back to the same value again. Just like think about the unit circle. So I'm going to subtract 2 pi from this, so 6 pi over 3. That's going to give me, that'll give me 8 pi over 3. That's still outside of 2 pi. I'm going to subtract another one. So that is equal to 2 pi over 3. So what that means basically is that 14 pi over 3 and 2 pi over 3 are the same. So I'm going to rewrite this a little bit, and I'm going to say this is negative 260 times the cosine of 2 pi over 3. Now that's plus 290, and I can actually do this. What's the cosine of 2 pi over 3? That's the cosine of a 60-degree reference angle in quadrant 2, so it's negative 1/2. So this is negative 260. This whole thing now is negative 1/2. That's what the cosine of 2 pi over 3 is, and then plus 290. So now it's saying, this is just saying it's 130, which is negative 260 times negative 1/2, plus 290. So at 14 minutes, right, h of t is equal to 420 feet. So you'd be 420 feet off the ground after 14 minutes. All right, and then the last problem, number 6, how long does it take to take the carriage at the bottom to first reach a height of 260? Okay, so we started right here, started at the bottom at 0, and now we're going to go up and we're going to try to get to, let's say, like that's 160 feet off the ground right there. And we want to know how much time has elapsed from the start to there. So we can do that too, because
that means the height as a function of time is equal to 160. So we set this function equal to 160. We say 160 is equal to negative 260 cosine pi over 3t plus 290. And we're going to be trying to solve this for t, which is something a little bit different. But we can do simple algebra here. If we subtract 290 from both sides, that's going to give us, excuse me for not writing that underneath, I'm kind of out of space. But this is going to be negative 130 is equal to negative 260 times the cosine of pi over 3 times t, right? If we divide both sides by 260 now, we will get 1/2, right? We'll have 1/2 is equal to the cosine of pi over 3 times t. And then look what this says, right? The cosine of pi over 3 times t, so cosine of pi over 3t is equal to 1/2. Well, think about where on the unit circle is cosine equal to 1/2. The first time it's equal to 1/2. And your answer to that should be that the cosine, the first time on the unit circle that the cosine is 1/2 is that cosine of pi over 3. So cosine of pi over 3 is equal to 1/2. And so if cosine of pi over 3 is equal to 1/2 and cosine of pi over 3 times t is equal to 1/2, the only thing t could possibly be here is 1 minute. So the answer to number 5 is height of 160 at 1 minute. And that's it. So we went from a problem where we didn't know that much, and we were able to figure out these answers. This might be useful to you if you were like wanting to take your like fiance on the high roller and like propose to them. And it's super cliche, and you wanted to propose at like exactly 420 feet for some reason. You would know to do that at like 14 minutes. You could do it at 14 minutes if you wanted to.